Interpolation is very widely used concept in engineering. Interpolation is used in subjects like thermodynamics, hydrology, etc. Recently held JEE Mains exam results are also compiled with the help of interpolation.
What is interpolation? It's a method of finding unknown value that lie in between the known values. Let's understand this with an example. Consider two numbers, 6 and 10. Let's plot these numbers on two reference axes. Number 6 and 10 are at some distance from vertical axis. We are not bothered about the distances yet. Let's say you want to find a number exactly in middle of these two numbers. Maybe intuitively you will say that this number is around 8. I do not know how you have figured it out. Maybe you have taken average of two numbers. That is 6 plus 10 divided by 2, which is equal to 8. Or you may have guessed that 8 is equidistant from 6 and 10. Congratulations, you have done interpolation. Interpolation consists of two words, that is inter, which is between, and polation is to put a new material. So by putting 8, you have put a new material between 6 and 10, so that is interpolation.
In fact, with this calculation or intuition, we are assuming there is a linear relationship between 6 and 10.
Linear means pertaining to straight line, but the relationship may not be linear. So if a function is linear, the middle value will be 8. But if the function is non-linear, then the interpolated value, like this and this one, will be different than 8. We will only focus on linear interpolation in this session. If we want to predict the number at the middle only, then this method is sufficient.
So if we want to estimate a number at a location other than the middle of these two numbers, then we need to know the exact location of the point at which interpolated value is needed. We can find the location by noting the distance from this vertical reference axis, that is y-axis, or either of these two numbers. It is important to realize that the interpolated value will always be in between two extreme values in case of linear interpolation. In this case, between 6 and 10. We need to understand the concept of slope to derive the generalized formula for interpolation. We will use Geogebra to visualize the concept of slope. Geogebra is a versatile software which combines geometry and algebra. It's also free to use and useful in understanding various geometric and algebraic concepts. Let's see Geogebra in action. Slope is defined as a ratio of vertical distance to horizontal distance. Consider a straight line. As we move along this line, horizontal as well as vertical distance will change, but slope will remain constant. Slope will only change if we vary one of the distances, that is horizontal or vertical distance, keeping the other fixed. This can be done by rotating the line by keeping one end fixed like this. We'll now try to develop the generalized formula for interpolation. Consider again two reference axes, x-axis and y-axis. This is point A having coordinates x1, y1 and point B having coordinate x2, y2. We assume there is a linear relationship in between A and B. Point C, which lies between A and B, is having a known distance x from y-axis. We need to find the value of y. Point A, B and C are at a distance x1, x2 and x from y-axis respectively. If we draw a line parallel to x-axis from point A, we can find AD, which is equal to x2 minus x1. Similarly, we can find BD, which is y2 minus y1. So, the slope of line AB is y2 minus y1 divided by x2 minus x1. Unknown y can be found out by using two formulas. First one is y1 plus slope multiply x minus x1. Secondly, y can also be found out from y2 minus slope multiply x2 minus x. To develop this formula intuitively, we will again take the help of Geogebra. We have two known numbers here, A 46, B 1210, and one unknown point C, whose location we can shuffle around like this. We can rewrite the slope formula as vertical distance is equal to slope into horizontal distance. Now, if we know the slope and the horizontal distance, we can find the vertical distance. Knowing the vertical distance cm as shown here, we can find interpolated value y, which is equal to cm plus 6, where 6 is coordinate of A, which is y1. Let's keep horizontal distance as 5. We will get y as 8.5 as shown here. Horizontal distance is nothing but x minus x1. So we get the formula y is equal to y1 plus slope into x minus x1. Let's apply the formula directly, and taking A46, B 1210 and C at a distance of 5, we will get value of 8.5. Let's again go to Geogebra to find y from second formula. Let's keep the location of C as same. Now its horizontal distance is 3 from Bn, which is nothing but x2 minus x. Using the same formula, vertical distance is equal to slope into horizontal distance, we can get vertical distance, in this case Bm, equal to 1.5. Therefore, y will be 10 minus 1.5, which is equal to 8.5. So we get the formula y is equal to y2 minus slope into x2 minus x. Again, applying the formula directly, we'll get y equal to 8.5. Seeing both side by side, we can see that we can get the interpolated value from either horizontal distance. Let's do an example from JEE. Here we have 3 candidates, A, B, C, and 3 percentile scores are given. Session 1 raw scores are given for A and C candidate. There is need to predict score for candidate B. Writing percentiles in terms of x and scores in terms of y, and applying the formula, we'll get y equal to 158.95, which is interpolated score of candidate B. If you are wondering from where this candidate B has come, who has percentile but no session 1 score, so this candidate is from some other session. Now we have finished interpolation. Here is a bonus topic, extrapolation. It's a type of estimation which is done beyond the original range. So if you want to predict a number whose location is outside these two numbers, then that is extrapolation. Again, we need to assume a relationship or function in between 6 and 10 and extend these function beyond these two numbers. Here we assume a linear relationship between 6 and 10 and we extend this relation. We can then predict the number at the required location using appropriate formulas. Thank you very much.